So great to have all of you from across the world in this session. And these sessions are known for their questions as well as the attendees and diversities from across the globe. All right, so feel free to ask questions, but the way I'm going to go ahead is that I'll first take you through the concepts, then I'll stop and answer your questions. So the way I'm planning to do is 30 minutes theory and then 30 minutes questions and then 30 minutes theory and then questions. All right. So feel free to introduce yourself over the chat window. And if you have questions, ask using the Q&A window. All right. So this is the first Q&A session on AI for Managers course. So this is the AI for Managers course that we have introduced. It's a unique course across the world in the way that it basically introduces the entire detailed concept of machine learning and AI in detail, like how exactly the algorithm works without using the code or without using the maths. And there's a beauty about this course that you will understand deep dive machine learning even if you have no background in programming. All right, so we'll have a 10 minutes break. We'll start, first we'll have an introduction, then 10 minutes break, and then machine learning process we'll cover. And please introduce yourself using chat window while others are joining. Session is being recorded and recordings and presentations will be shared with all of you. This is the first of Q&A session on AI for Managers course. It suffices as introduction to AI and machine learning in general. Even if you have no background in technology, no background in computing, I urge you to stay back and attend the whole session. I'm sure that you're going to learn at least the basics of machine learning and AI today. Except for me, everybody is muted. So please ask questions using the Q&A window. It'll be very hard for me to look at the chat window because there are too many messages continuously scrolling. So I'll read out the questions before answering so that we all know what I'm talking about. So please keep your messages short and avoid chat language. I'm not that good with chat language. To get better answers, please keep your messages short and avoid chat language. I'll try my best to answer your questions. All right, so to understand more about this particular course in detail, please take a look at the website that we have, and I'll just take you to the website and that'll give you an idea about what we do in general. So just give me a moment and then I'll walk you through. Okay, so if you go to cloudxlab.com, you will find this course there. All right. Let me select all panelists. And okay, thank you, Aswat, for sharing that. So please take a look at the courses, and these courses are well known. And take a look at the Quora reviews for us. Those are real reviews by real people, and I'm sure that that'll help you understand how confident are we about our quality. All right, so now going back to the presentation and moving ahead. All right, let me make it full screen. Wonderful, wonderful. Hello, everyone, and let's get started. Perfect. All right. So please ask your questions using the Q&A window. I'll answer your questions every 30 minutes, probably 8:30 I'll start answering your questions. And then till then, I'll just cover the theory part so that we all are on the same page when we talk about this, okay? So in this particular course on AI for Managers, this is the first chapter in which we cover two topics. One is introduction, other is machine learning. And in introduction, what we're going to do is I'm going to give you a quick overview of what is machine learning, AI, and then we will dive deeper into your questions, okay? All right, and I'm sorry for this typing mistake here. I've just created this, so don't worry about this typing mistake. All right, so wonderful to have people from all across the globe in these sessions. And so welcome to the introductory session on artificial intelligence and machine learning by CloudX Lab. And as part of this introductory chapter, what we're going to do is we're going to learn about what is artificial intelligence, its sub-objectives, and how to achieve the AI. And then we will understand what is machine learning and deep learning. And we will end the chapter with the use cases of AI in various industries. All right. So AI, or artificial intelligence, is everywhere. AI is going to be at the heart of every product or service. Today, it's powering various high-tech products in our lives. For example, it is powering the speech recognition in smartphone, recommending products, and driving the driverless cars. Let's see some examples of AI-enabled products and services. The self-driving cars, also known as autonomous car or a driverless car, are capable of navigating without any human intervention. Google has built a self-driving car called Waymo, which has already driven 1 million kilometers. And at the same time, many other companies, such as Apple, Uber, and various car manufacturers, are testing. So driverless future is not too far. Now, most important part is that maybe the driverless car is not going to be the current into the streets right away, but the technologies that have been invented because of the self-driving cars are actually impacting the entire automation industries. All right. Now, with the advancement of AI, the human-like robot have become possible. One such example is Sophia. It was developed by a Hong Kong-based company called Hanson Robotics, and it has participated in many high-profile interviews so far, and that's something hard. It became the first robot to receive the citizenship of any country. On the other hand, NASA is using AI to discover life on other planets. Now, you might wonder that maybe the AI is not for us, but the important part is that these inventions that you see right now that I'm talking about, they may look like too high profile and not for the common people, but the truth is that almost every device, be it Alexa, be it, let's say, your normal television, be it your mobile camera, and so on, everything has got machine learning or AI in some form or another today, and it's improving. All right, it's improving. So now what we're going to do is we're going to talk about what is AI. In simple words, AI is the intelligence exhibited by the machines. It's the intelligence, it's basically the objective. AI is not a tool in itself. When something behaves or shows certain intelligence, the way we define intelligence, we are going to talk about it very soon. And the way a certain robot is behaving, we call it intelligent. I'll talk about what is it mean by intelligent. And this whole intelligence is called artificial intelligence. When we say that, is AI going to solve this or something? We are talking about the underlying tools and technologies that achieve AI. AI is just a noun. AI is just an objective. All right? Now, when we talk about AI, We're talking about these intelligent machines perform tasks which require human intelligence, such as visual perception, ability to see and observe, speech recognition, the ability to recognize voice and infer its meaning, and making decisions. So how did the idea of AI originate? It's not new. We have always been fascinated by creating the human-like machines, not only today, but even in the Greek mythology. When we talk about Greek mythology, there was a person called Talos, which was basically a humanoid machine, which is an example of our fascination with humanoid or machine created intelligence. Similarly, the Frankenstein monster in Mary Shelley's novel is another example. So we have always been fascinated with this idea of creating the machines which act like human or animals. The term AI or artificial intelligence was formalized, or you can say coined, though it has been there for a very long time, but it has been formalized by John McCarthy along with Marvin Minsky, Claude Shannon, and Neil Rochester in a conference in 1956. The workshop or the conference was at Dartmouth College in New Hampshire. And this conference basically was around AI, and they coined these 5 terms. So they basically came up with the idea that there should be sub-objectives of AI. They said that in case something is able to achieve these 5 sub-objectives, we will call that as artificially intelligent. If something is able to represent knowledge, have the perception, do the reasoning, navigate, and do the natural language processing, we will call it intelligent or artificial intelligence. So to further elaborate the meaning of this, meaning of the AI, John McCarthy defined these sub-objectives, these 5 sub-objectives that you see on the screen. All right. So in order for a computer to accomplish intelligent tasks, we need to be able to teach computers to represent knowledge. The knowledge about the real world. Knowledge about the real world. So the first sub-objective is to represent the knowledge. It needs to understand the meaning of objects in real life. What does a man mean? What are people? What is a language? For this purpose, programming languages such as Lisp were invented, but it did not work out much because we were manually defining the meaning of objects and their behaviors. Now, this amazing part about representing knowledge has been recently advanced really well. If you, as you proceed with the course further, we'll talk about something called word embedding. In word embedding, we basically let the computer understand the meaning of words. And it is so good at it that it understands that if you take a word called king and you subtract the men from it, king minus men plus woman, it gives answer as queen. And today we were doing this discussion and I was showing that if you take emperor, subtract men from it, and add woman to it, and I was amazed to see the answer. I took emperor as the word, subtracted man from it, and added woman to it, and you guess what was the answer? The answer was yes. Anybody? Emperor minus men plus woman. Yes. Anybody? Yes, that's right, Raghu, Vijay, and Gabriel. Yes, the answer was actually Empress. Okay, so that's the state of able to represent knowledge, understand what it means by various words, and so on. And that's like amazing part of the of the AI or machine learning today. Okay, so the first objective seems to be met to very large extent. Unlike the olden times when we were doing Lisp, it did not work. The second sub-objective was perception. An intelligent machine should be able to perceive the real world object using sound, sight, or touch. That's the second sub-objective. For example, when you use Xbox Kinect, it analyzes our dance steps using camera and infrared sensors, and then it rewards the points based on the accuracy of dance steps. Perception plays the central role in the self-driving car. Okay, so essentially, that's the second objective, the perception. The third objective is reasoning. An intelligent machine, other than being able to perceive and represent knowledge, it should be able to reason out. An intelligent machine should be able to reason out things. It should be able to play games, make logical inferences about medical diagnosis or mathematical theorems. That's the third objective. The fourth objective or sub-objective of AI or intelligent, when we call something as intelligent, is being able to navigate or planning, such as driving car or making a move, robot making a move from one place to another. So an intelligent machine should be able to move from one place to another. Navigation is a very hard intelligence to build in the machine, because how does it go from place A to place B? How do we locate the destination? Is it a door or a wall? Or is it uphill or downhill, and so on? There are like many hard problems to solve there. These are planning and navigation tasks, the one that I just talked about. We should be able to teach computers on how to plan and navigate. Or, in other words, the artificial intelligent being should be able to come up with its own planning and navigation strategies. I'm going to show you Mario, how computer plays Mario just after this, and you will be amazed at its ability to plan and navigate. The fifth objective is natural language processing. An intelligent machine should be able to understand, speak, and translate languages. As of today, it has become really close to reality. Very close to reality. The fifth objective, the natural language processing, is again, we are able to achieve a large amount of we are able to achieve this at a very large scale. And that's the amazing part of today's time, that natural language processing has become close to reality. We have Alexa, we have Google Home, we have so many other systems. Or you take a look at the Google Translate. It is able to translate from one language to another. And that's based on the machine learning or AI. Now, that's basically the computers are able to learn the meaning of words, and by reading through the text from World Wide Web, it's able to infer the meaning of words, and that has led to an entire new revolution about understanding the natural language. Now, the hypothesis in that conference, where the meaning of AI was defined by the way of sub-objectives, the hypothesis was that if the previous sub-objectives are achieved, the following should emerge automatically: the emotional intelligence, creativity, intuition, and reasoning. And I'm going to show you as an example, when I show you Mario example, that how this intelligence automatically emerges. This intelligence automatically emerges because of the previous objectives being met. Okay, so hypothesis was that in case we are able to achieve those 5 sub-objectives, the generalized intelligence would emerge automatically. All right. So now question is, how do we achieve AI? What I just defined was the definition of AI, or how do we say that this is artificial intelligence and that is not, right? That's what I've defined so far, the meaning of AI. Now let's see, how do we achieve AI? AI is achieved, there are many components, many things that are needed to achieve true artificial intelligence. One is the hardware, the robots, IoT, the Internet of Things, or sensors. So on one hand, we have the hardware, robotics, the IoT and sensors and so on, that's needed to achieve AI, or to build a being which is similar to humans. Second is the software. The software part is basically a bigger part actually, right? In some cases, bigger part, and in some cases, hardware is the bigger part. Is really not possible to compare because both are needed for the artificial intelligence. Now, hardware, robots, and sensors are also needed elsewhere, right? Do you see this part? That means that this hardware, robots, or sensors, they basically are also needed elsewhere other than AI, right? Any of you, are you using any robotics at home? Anyone? I've been using robotics, some tool based on robotics. Yes. And we can't call it artificially intelligent. Yes, anybody? You can answer using chat. Okay, I'll keep my Q&A window a little pristine. Roomba is intelligent being. You can call it artificial intelligent to some extent because it can plan, it can navigate, it can sense, just that it doesn't know much of reasoning or much of natural language yet, but it's not too far to do that. Okay, so what is that thing at your home which has robotics but is not intelligent? Yes, good. Thank you, Satyajit. Washer, dryer is basically an example, or printer is another example. Perfect. So, good, great. So, next part is software. Similar is the story of software, that some parts are overlapping with artificial intelligence, some part is not, right? Making a website and it's not, and uploading data from here to there, that's not really part of the AI. But if the same thing is done in order to achieve AI, then this part is that. Now, we can use the rule-based programming to achieve true AI. You might have to use rule-based programming. For example, Alexa, or for example, say Google Home. There are a lot of rule-based programming where they have hooks that in case you sense this, then do this. So it, to a very large extent, even really artificial intelligence, intelligent things are also having rule-based programming. Though rule-based programming is also used elsewhere in the world, rest of the software. Second is the machine learning. Though this machine learning is entirely overlapping, as in it's completely part of artificial intelligence. So machine learning is machine learning from data by their own. We are not coding, we are not programming, we are not writing rules for machine. I'm going to talk about it in more details. So machine learning is a branch of AI whereby the machines learn from data by itself. We don't write the code. We don't write the rules. Then further, a part of machine learning is called deep learning. This deep learning is essentially machine learning built around the idea that the animal's brain, the way it works. So deep learning essentially is a machine learning models that are built around the idea of the animal brain. In summary, AI is the end objective of this. AI is an objective. while software such as machine learning and deep learning and hardwares like sensors and robots and so on are just the tools to achieve AI. So AI is an objective, and software and hardware are the tools to achieve AI. I hope you got the difference between AI, machine learning, deep learning, software, and hardware. All right? Right. So I'm going to walk you through what it means by machine learning. It was a brief introduction of AI. I think that's the only introduction we have of AI. Rest of the course is about machine learning because AI is the objective defined, and machine learning is the biggest piece or biggest puzzle of AI. Machine learning is the biggest puzzle. No, so let's understand what is machine learning. All right. I'm going to give a break after the definition of machine learning, and then we'll take questions. We'll take questions after the definition of machine learning, and then we'll go into deep learning. Okay. Perfect. So, what exactly is machine learning? Now, this is the classic definition by Arthur Samuel in 1959. Now, the classic definition is the term machine learning was coined by Arthur Samuel in 1959. Machine learning is the science and the art of programming computers so that they can learn from data. Okay, so we will have to feed the data over and over to the machine learning algorithms, and it'll figure out the way of solving it. Now, the question that you might ask that, then why are we studying it when it can figure out by itself? We will have to translate data in certain form, and we have to ensure, just like a teacher ensures that the kids learn, similarly, as the engineers, as the managers, we need to learn how to format the data, how to format the example data so that the algorithm can learn. All right, therefore, we are studying it. Right now, this definition of machine learning may not make sense to you right now, but let me take a very good example. Let's understand the meaning of machine learning with an example of Mario game. How many of you have played Mario? Yeah. Nobody? All right. Yes, probably everybody has played. Now, question is, were you able to achieve the princess? Wow, there are quite a few people who have achieved the princess. Wonderful. Now, can you believe this part? That can a computer also learn to play Mario by itself, just like us? Just like us humans, can a computer also learn to play Mario by itself? So it's a little older example. So Tom Murphy 7 from CMU wrote a program which learns Mario game by itself. Now, those who are interested in Mario game, even those who want to play the Mario game even today, what they can do is they can install this something called Mario Simulator. It's called SNES Simulator. And then in that simulator, you can load the program and you can play on your computer even today. So in that simulator, what he did was loaded the game and then hooked the software to the simulator. So the SNES simulator was running the Mario, and the software was hooked to it. Now, what it does is, what software was doing is, it was playing the game like us, observing the memory which keeps the screen, because the screen is represented as a memory, and it was observing that memory in the simulator just like we observe the screen. So it was observing the screen, it was observing the score, and was pressing the keys. That's what the software was doing, and learning from it, learning from it. He did not coded what is the meaning of gravity. He did not define collision or anything. It's the program that learned to play Mario by itself by playing over and over again. Now let's take a look at this example. Let's take a look at this example. So on day zero, the program is pressing the keys randomly, and Mario is not moving anywhere, and it dies of old age. It's like an infant. On the day zero, it falls down. Now, couple of tries, multiple days over, this is the state. It's a little better, but it learned by itself that it can move and can achieve something. The only problem is that it's facing the other side and it's badly stuck. After a few more weeks of trying by itself, this is the current state. You can see that? This is the current state. Now it's able to play a very decent. It's kind of able to sense sense what is coming next. Do you think he'll be able to press? Yes? Or is he stuck? So you can say that, yes, to a very large extent, machine learning is a bit of trial and error. And we are going to talk about it in more details. That what does it mean by trial and error? Now you're going to see something really amazing. Something really amazing. That what was that? What was that? When Goomba was falling on it, it started moving downwards, and then he got the point. So the program figured out a bug in the game, that it can exploit the bug in order to achieve the score that we never knew. Nobody ever knew that such a bug exists. Now here, program is again exploiting another bug in the Mario game, and no idea how did he do that. Now you're going to see something more important. So here, program is stuck and it's not able to move ahead, so he pauses the game. He pauses the game just like in the childhood. Our siblings spoiled the game when they could not win. Similarly, when program was not able to win, it kept on pausing the game because it did not want to lose its score. That was the only way to retain the score, by pausing the game. So that was an example of what is machine learning. So without teaching how to jump, without teaching what does it mean by gravity, what does it mean by collision, what does it mean by different colors, what does it mean by edges, we did not teach the program. We did not teach the program how to do all of this in the game. It figured out by itself that this works, this doesn't work, this works, this doesn't work. And by over and over trying, it learned the right things. It even learned that there's a bug in the game that we never knew of. So that's the amazing part. And that's what defeated the world champion of a game called AlphaGo. It kept on playing against itself and figured out how to play a game called Go. And basically the world champion was surprised and shocked when the program won against the world champion. It was, the moves were very strange. Nobody ever saw those moves, and it won. Had somebody coded these moves, had I coded the moves in this, probably Mario will never get the princess, because I myself have never achieved the princess, right? So there's a limitation. There's a limitation when we write the program, which is rule-based. It has the same limitation that we ourselves have. So if we have not solved the problem, some problem, program may not able to solve that problem because we are actually codifying those rules. The only thing we could do is we could try an infinite loop and try all possibilities, but that's not the way it works. Okay, there are two things that I have just now. There are two things that somebody has mentioned. One is, wouldn't it get stuck in an infinite loop? Second is it learning through trial and error? These doubts will get clear as we go ahead in exactly how machine learning works. I'll make sure that I'll make it very clear that what it means by these terms. Okay, so let me move ahead. Now, question to all of you is, what will you do to make this program learn any other game such as Pac-Man? Option 1 is write new rules as per the game, or just hook it to a new game and let it play for a while. Yes, 1 or 2? That's right. That's right. So the answer is 2. Just hook it to a new game and let it play for a while, and it'll figure out all the ways to achieve a great score in almost all the games. Though it does get stuck in some of the games, but there are newer techniques that are being explored as of now. There are newer techniques such as learning by curiosity and various other strategies that have been tried out now. Question from Thiru is that hook what? So hook it to the new game, as in hook the software to the new game. Let's say this program, the one that was learning, the machine learning program, if you hook it to a new game, will it learn by itself or not? Okay. That's what I meant by just hook it to the new game. All right. So all right. Now I'm going to, before I jump into the machine learning examples, I'm going to answer your question, Sue. So Vigi, yeah, you can ask the question in Q&A window. I'm going to take questions from Q&A window from top down, and then we will go back. All right. So one question is, what's the difference between AI, ML, and DL? So AI is the objective. ML is a part of the software that learns from the data, and DL is a class of algorithm under machine learning, which basically is designed based on animal brain. All right. I hope you got the answer to this one also, Anup. Question is, how do machines collect intelligence as AI? Okay, so I'm going to go into more details as we go ahead, and then probably you will get a real idea about how exactly a machine learns. A question is, I want to deploy my Python ML model to a web server as backend service. Is it a good idea to pickle it? Yes. Just take a look at one of our blogs. Go over to CloudXLab/blog. Okay, there you will find this. There you will find a blog post which talks in detail about how to launch your machine learning model as a web service. Okay, in detail, step by step. So I would request you to go over to the blog. If you want, I can just guide you here. Okay, so CloudXLab/blog. Okay, so here we have, yeah, this one. Okay, take a look at this one. This is a way of launching your model. I'm going to post it in the chat. Okay. All right. So yes, now we're so I'm going to keep one window open that says Q&A. I'm going to take the Q&A now. Okay, let's just change the font to really large. Okay, so I'm going to take the questions from the, how can I keep it at the top? Okay, here. All right, perfect. So let's just move on with the questions. A very interesting question is, isn't coding more efficient than learning from the data? It's a very important question. So question is that here we hooked the program to the game and we left it to learn. So it took long time, weeks of time to learn by itself. So isn't coding more efficient than hooking? Now, here's a question to you. it's the way you define efficiency, right? So coding might require really good programmers to code the entire rules, but it would never achieve the intelligence beyond what you have thought. Now, every time you have got new game, you will have to hook it, you write the new code and so on. And you will have this bundle of rules, and every time game updates or something, you'll have to again go over and write the new rules and so on. And that's the reason why I'm going to take a bigger example of spam filtering. Earlier, filtering the spam, the one that you receive in your inbox, figuring out whether an email is a spam or not, was actually rule-based. And that did not solve the problem because people could, the spammers kept on figuring out all the rules that you wrote. And that did not work out. Okay? Therefore, though coding is efficient in the cases when you don't have data, right? When you don't have data, when you can't generate too much of data, in those cases, coding is the only solution. But if you have data and you have the opportunity to learn from data, probably making a machine learning model is generally a wiser approach. All right. A question from Satyajit is, what's the difference between test and validation data? I'm going to talk about it soon. Okay. I'm going to talk about this part soon, but let me just give you a quick, those who are not from the machine learning background, they might find this question daunting. Question is that generally we use two terms called test and validation. So though we use both the terms test data and validation data interchangeably, but validation have another term called cross validation, in which what we do is in the test data, training data itself. So I'll actually talk about this at a later point of time when we talk about the machine learning process. Okay, just give me some time. I think that'll be a wiser thing to do. A question from CJ is, by your definition logic, would IVR call on telephone be classified as AI? So yeah, good question. Good question. So anything that's actually a very important part about it. So the way AI has been defined, it's a good question. So the way AI has been defined is in a very generic way. Anything that behaves like intelligent being somehow portrays themselves as AI. So yes, you can, in a way that IVR calls, some people, if those who are running the call centers, they can say that, okay, we are also doing AI. Okay, that's the way it is almost. That's how the evolution of marketing term happens. But it doesn't, in case it's figuring out the voice, if it has any of the sub-objectives that I talked about, then we can say that the 5 sub-objectives that I talked about, if it has even one, then that's good enough to call it artificially intelligent. Okay. A question from Kosaras is that AI will take decision on data classification or rule-based program. Good question. Good question. So in case of AI, as long as it's meeting any of the sub-objectives, we are okay with the approach, whether it's rule-based or data classification, right? But to achieve those sub-objectives, the chances are that you will have to use some automated learning, some non-rule-based approach, some approach which learns by data regression or classification. I'm going to talk about what it means by classification soon. All right, great question. So a question from Vijay is, I get the DL part. The DL is a part of ML, but I'm unable to still get how AI and ML are different. Can we say that AI is setting the rules and coding and setting the rules and coding, and ML is letting the machine learn? So, so again, let me just go back to the diagram that will make it really clear to you. Okay, this diagram should make it clear to you. Okay, so in this diagram, what we have is AI is an objective, while software or hardware are just the tools. Machine learning is a part of the software or the program or the algorithms or the models that basically learns from the data. So you can see that machine learning is a part of software, similar to rule-based programming. and the AI is just one objective. AI is the objective, while the hardware and the software are the means to achieve it. Okay, I hope this diagram makes it clear. Wonderful. Moving ahead, so question is, I have experience 15 years in IT industry. If I move on to AI, then I'll be fresher in this area and my experience will be of no use. Please let me know your thoughts. So the way computing cuts across the entire industries, whether it's manufacturing, whether it's transport, whether in almost every industry, the computing has cut across. Okay. Even the cement industry, manufacturing plant, everywhere, if you know a bit of programming, it's going to be helpful. And it's completely okay. So if you take a look at, the, let's say, process engineer at say, cement plant, if he knows like the control, programming and knows a bit of process PID controller, then the chances are that they will do pretty well in the job, right? Similarly, almost every industry has been impacted by computing. And in the same way, AI is also impacting the computing. Wherever there was computing, instead of writing rules, we are figuring out the rules based on the data, and that has made something which is really impossible possible today, which looked very impossible a couple of years ago has become possible now. And I'm amazed to see the intersection of AI with almost every vertical, the way computing has the intersection of with almost every vertical globally. Okay. So it won't be of waste to learn about AI machine learning, because this area is going to cut across almost every vertical. Question is, I would really appreciate if I'm giving a simple example that will engrave this difference in my mind. Yes. So question from Vijay is that, can I give an example of AI? So when we have, let's take an example of Alexa. You use Alexa, right? In the Alexa, what you have is you say something and it interprets it and then does something. Now, in Alexa is an AI. You can say Alexa is artificially intelligent object. Okay, it has a hardware, right? And it basically has rule-based programming, and it has a machine learning component to it, right? So this way, and in many cases, like natural language processing, there's no hardware involved. It's just pure software, and there might be rule-based programming or the machine learning in that. All right. A question from T2 is that, can you discuss some application enterprise software world for AI? Yes. So again, whether in case of enterprise software world, whether it's optimization of let's say your say OCR workflow, or the other workflows, let's say you want to, in my case, the example was that we had these on our website, there were images which we needed to because these images was posted by many people, so we wanted to classify them and mark which one is a spam, which one is not. Almost everything I'm seeing today is going to be impacted by the various AI use cases. All right, it's just the way you look at it. But yes, it's a detailed discussion I can have. I probably can note down and publish in more detail that what all enterprise and in how many ways the enterprise software world is going to be impacted by AI. All right. A question from Anup is IoT is a part of AI or ML? IoT is a connected world of sensors and technologies. It's part of basically, it's not really part of AI. The AI could use some part of IoT. when we want to sense the environment and so on, in order to achieve intelligence. In order to achieve AI, we might use some part of AI, IoT. All right. A question is, so basically to build on AI, we need software, ML, yes, hardware. That's right. Good. What is a neural network? I'm going to talk about it, and very soon. Great. A question from Erika is that, can we track all the steps, the trial and error analysis process? Yes. I'm going to go into more detail about what does it mean by trial and error, and how can we track all the steps. Okay. Wonderful. So it has to have all the sub-objectives, or just one of them is considered AI. Actually, that's an interesting part. So yes, ideally it should have minimum of one sub-objectives, and that's how, though for truly defining AI, you need all 5 sub-objectives to be fulfilled. But even if we have one sub-objectives, we can say that this seems to be an artificial intelligence. Okay. But as part of main definition, if something is able to achieve all the 5 objectives, then we call it an artificial intelligence. Question is, what kind of data for machine learning, specifically reinforcement learning algorithm? So reinforcement learning algorithms, so, okay, those who are not aware, what we saw in case of Mario, the one that I showed an example of Mario, where Mario was learning by itself. What it was doing is it was generating data by itself, right? By playing over and over again, it was generating data. Therefore, in case of reinforcement learning, it should be able to generate the data, okay? Question from office is that, may I know how much accuracy you got? In which case, I kind of missed the context. There are quite a few questions, so I can answer over the email. Okay. Also, we have this wonderful forum. In case you're not aware of, and if you're not there, come over to the forum. I would love to answer your questions. There are really more detailed discussion that keep on going there, and this is the discussion panel. Okay. All right. Can you discuss some application? Sure. I'm going to discuss that part. Okay. All right. A question is, so isn't it dangerous to let machine hook? Considering every domain, there may be anything to stop the machines. Good question. It's about the probability. If we know for sure that this device works, the software works, this pet doesn't bite, right? Then we will be okay. If we know the accuracy of it, if we know that my pet will not bite me, we are okay living with it. Similarly, if we know exactly how machine learning algorithms are behaving, we will be able to build a trust. We'll be able to understand its behavior when it misbehaves. Okay, so at some point of time, you will see that lots of people are very paranoid, of the computers, right? As well as they were very paranoid of if people who are trying to fix their computer, then no, don't touch my computer, something might happen, right? What exactly is the reason behind that paranoia? The reason is that they did not have the understanding of how exactly it's happening, why exactly it's happening. Once you get an understanding of how exactly machine learning model is working, or how exactly to tame it, or how exactly to measure the performance, and how exactly to define the performance, as in, should it be accuracy, should it be precision, should it be recall, should it be something else. So if we are able to measure the performance or define the performance and then measure those criteria of performance, we will be less paranoid, and we will be able to decide whether to risk or not risk. Okay, so that's more important part. If we know, if we understand the limitations, the limitations of the model, then we'll be able to decide whether it's okay or not okay. All right. So important part is understanding how dangerous it is, understanding what it mean by dangerous, understanding the limitations and understanding the advantages would help you take this call. It's a very important question. Question is, if you have to hook the model to a new game, how can I do for new features? It is going to learn by itself. It's going to learn by itself. Okay? You don't need to worry about the features as long as if the screen size is changing, probably then you might have to change the way you were reading the data. If it's a new machine, completely new machine, it's instead of SNES emulator, it's let's say some other emulator. In those cases, you might have to change the game so that instead of looking at a particular memory address, it'll look at some other memory address. Right? That's the only change you will have to make. All right. Question from Manish: Can .NET application use an AI-based model, not programmed one? Yes, definitely. Almost AI or machine learning algorithm can be invoked from almost every programming language. So don't worry about it. If you are comfortable with .NET, you can use machine learning using .NET. The link that I posted, deploying model in production, will answer you better. Smart car parking is an example of DL or machine learning. So DL or machine learning is the underlying approach. Okay, so and DL is a part of machine learning. Deep learning is a part of machine learning. So anything that is deep learning is also machine learning. Okay, so smart car parking is again an example of machine learning. All right. A question from Rico is, what kind of data for the machine learning, especially for reinforcement learning? So yeah, so it's basically automatic learning. I've already taken that. Now, question from Gabriel is that I'm a UX design. Do you have any comments about how AI and humans can interact with one another, and importance of making sure that data we provide to ML and AI's goal is aligned with human goals, so people don't get scared of having killer robots? Okay, so okay. All right, that's kind of a social debate. I would leave that to lawyers of the world. And I'm definitely not qualified to answer that question. But yes, there's a lot of scope that is there in the UX design, whereby we can use the machine learning, as well as we can use the UX design in order to make it more humane. Okay, humane is the keyword in the UX. Okay, also you can take a look at the new models. One of the things that we did long back at one of my companies is that we did the UX testing using the bot, using the program. The program was looking at our web page and seeing that, okay, which part is overlapping, which one is not, and which one looks claustrophobic, which one looks okay. So that kind of work, that's where we used the AI in order to improve the UX design. The other part was how will something look to colorblind person. So that those kind of there are lots of use case in case of UX design for machine learning. All right. A question from Uba is that can you break down the example of Alexa furthermore? Yeah. So in Alexa, there are many parts. One is voice-speech synthesis. The second is the rule-based engine. Third is inferring, before the rule-based engine, the third one is inferring the rule. So first is converting voice to text. Second is converting the text into the context and extracting what is it that we are trying to call the command. And then based on the rule-based approach, we pick which route to take, and then answer based on that. So there are multiple parts. So in one of the chapters, we actually break down the Alexa to a very detailed level. The question is, in AI, if you're going to get the data from different sensors, sensor systems, those are maybe different format. Do you have any awareness how AI going to classify the data and take decision? How much perception will get from AI objects? In AI, if you're going to get the data from different different sensor systems, okay, those are maybe, yes, that's right. Do you have any? Yeah. So good question, good question. So most of this data extracted from different sources need to be used in a way that when we are feeding that to algorithm should at least know the structure of it, okay? Or at least the algorithm need to know that it's completely unstructured data and we'll feed it, okay? So at least we should be aware that the format of what is the format of the data so that we can customize our machine learning algorithm to consume that format, okay? So, but it's a hard question to answer. And this is something that is part of the design. No matter how much we say that it's completely automated learning, but at least this part we have to do while hooking a machine learning algorithm to various data sources. We need to know the formats of the data, at least to some extent. Okay. The next question is, what all technologies you should be well-versed before starting or jumping into the AI and machine learning? Please tell us in detail. This course, the one that I'm talking about, this is the first session of that course. In this course, what I've done is I've extracted, I've designed the course in a way that you don't need to really know maths or programming to understand AI and machine learning. And that's the hardest part that we have solved as part of this course. Okay? And I can assure you that even if you're not from mathematical background or programming background, you will be able to understand how exactly the machine learning algorithms work and how can we trust them to use them. So that's the part about this particular course. So honestly, you don't need to know much other than basics of computers in order to jump into AI. And that's one hard thing we have done as part of this course, that you don't need to really go about all the way in order to, like, you have to first learn maths, programming. No, you don't need to. That's the one that we have done here. And further, if it is interesting to you and you are very much interested in programming, you can go ahead and learn programming and start using it. Okay? All right, I think I have answered your question, Gabriel. Okay. All right. Smart city is an example of machine learning or deep learning. Smart city is a composition of multiple things. It is composition of IoTs, machine learning, and deep learning. It's the way you solve a problem. In one of the cases, I was recently helping somebody with the garbage bin collection. In that case, it's actually a very interesting machine learning problem. Okay. A question from Rico is, can you show that data? Which data are we talking about, Rico? Okay. Can you show that data for processing Super Mario Learning? Good question. So the question is, where was the data in case of Super Mario Learning? So what was happening there is that the program was hooked to the emulator itself. And the program was reading the data directly from the memory of the emulator. The way we see on the screen, it was essentially the way the program was interpreting it. And it was just looking at the image, because the screen is nothing but an image. So the way the program learned Super Mario was by looking at that image. And in that image, there is one particular location where the score is kept. Okay, the memory where the score is kept. The program basically used that as the objective. Okay, so we did not extract the data. We let the program pick the data from the memory of the emulator. A question from Iggy is, so is trust also a sub-objective for AI? Interesting question. So by that definition that we are following, Quick answer is no. A question from Tito is, are we going to do programming later in the course? No. In this course, we are not going to do programming, but there is one chapter in which we have exposed you to how to build a model end-to-end. In case you are more interested, you can take a look at the code and you will learn the programming the reverse way, as in looking at the machine learning, entire machine learning project and then walking backwards. So that's also another very interesting way of learning, but it's not really needed or mandatory. In case you're interested in learning Python, we have a very interesting course for free on our website, just that you need to take a lab subscription. That's very, very low cost. Okay. If you just came, we have the video. You can watch the video later. Question is, machine learning is a part of data science? Yes, you can say that. All right. So there's a huge part. Data science is a really, really big, large area. Even for non-machine learning tasks, we use the data science just for human analysis and visualization. And that's also part of data science, while machine learning is basically part of the data science. Okay. All right. I'm going to talk about neural networks very, very soon. Neural networks basically fit under the deep learning part. Here inside the deep learning circle is the neural network. A question from Alexandra is that last year I saw an announcement by Google and Microsoft. They were moving with machine translation. Yes, yes. So that has become the machine translation as of today. And I'm going to talk about the neural network very soon, so I think it's a time to move ahead. With all technology, you should be able to well versed. You don't need to worry about that part. Whatever is required, we will take care of that in the course. Okay. So take a look at the course on our website. Okay. The AI for managers. You will get the answer. Yes, neural network is part of deep learning. Yes. How was the machine learning done without coding data bytes? So I'm going to give you an example of what is machine learning and you will get the idea, okay? That I'm going to talk about soon. A question from Subhendu is that really we don't need programming to that high extent for learning. Yes, that's one thing that we have worked hard on so that you can understand machine learning without having to code. Right? The way we learned in our school, we learned about diesel engine, petrol engine, so much things without programming and maths. So I believe, similarly, as part of this course, we have designed it such that you will be able to understand machine learning without coding. And I can assure you that, okay? And those who were part of my Singapore talk would agree with me to this, that I was able to explain most of the algorithms without programming. Is it true AI will replace human workforce? That's a hard question, but the things that do not require too much of intelligence, like moving and so on, the jobs where we are just trading information from here to there, in those cases, the chances are that it'll be able to replace human workforce. But the complex tasks like lifting things and so on, those tasks are hard to achieve. Only specialized ones can be done right now, but even today, I don't see that it is going to replace it so soon. Okay, but the information intensive work could be replaced to a very large extent. Is it possible to learn how to program, develop one sub-objective or sub-area of AI, or is it important to learn everything, like learn how to program for NLP? So my suggestion will be that you go with the flow, the way I'm taking you through. More important part is to understand how exactly machine learning works, okay? And then understand each of the, how do you measure the algorithm performance, and so on. You will find that whenever you're building something, those things will be far more important. Those things will be far more important and you will be able to see it through. Okay, and also as part of this course, what we do is we do a hands-on with Azure ML without coding, and you basically drag and drop things and make it run, and you don't need to code. The ideas, the concept, and everything we'll explain, and then you will be able to build a machine learning project without programming. Okay, and whatever is needed as part of this course, we will be covering that. We have the videos already. Actually, I can't imagine the data from Super Mario learning before. Can you help me imagine that? So in the case of Super Mario, it's basically an image. Okay, every time what it does is it captures the image, the photo, or the picture, and then that picture is basically what? It's basically a two-dimensional data. It's like a picture is nothing but a matrix of data, right? So the picture is what? When you think about picture, how it's represented in the data is basically the intensity of pixels on the screen, right? If it is color, then there are 3 colors on every point. And that data is being fed to the algorithm and it's learning from that. Okay, this program will be, yes, it will be useful for .NET professionals, and because it's irrelevant, the programming language is irrelevant in this one. Okay, I'm going to talk about deep learning tools very soon, Ranjit. Okay. A question is this given a middle or higher salary if you're expert in AI machine learning nowadays? Yes, you can take a look at the jobs. You will get an idea about the salaries. Okay, what type of algorithms is required for machine learning? I'm going to talk about it, Anup. All right, great, wonderful. What are the programming languages for ML? Almost every programming language can be used as part of machine learning, just that some programming languages which are more efficient, okay, are used for designing the algorithm, though you can design all of these algorithms in almost every language. Okay, and generally the languages that are pretty simple, like Python, we use those languages to use these algorithms, but most of these algorithms are not really designed in Python because Python is not that efficient. Okay, most of these algorithms are designed in C, C++. So in case you're interested to know about that part, but don't worry about the programming language. Almost every programming language can do everything. Therefore, it's not about the programming language. It's about the idea. It's about the concept. It's about how it works. It's about how do we measure the performance, how do we translate data to feed to the algorithm, and so on and so forth. Perfect. So great set of questions. So, all right. So let's move ahead. So please ask the questions using Q&A window. Are you able to see the Q&A window? That's the amazing part of these sessions, that I'm able to answer so many questions. In none of my physical sessions, like the one in the Singapore and in Bangalore, we don't get this much time to answer every question. And the hard part is that not many people ask questions. And okay, so now coming back to it. So before we move forward, there is one quick answer. I'll just answer this question. Then we will take another set of questions after, say, 30 minutes. Okay. A question from Albro is that why Python is a popular machine learning language than others. One is Python is simple. Using Python, calling the other programming languages is very easy. And Python is since it was easy to type, there was less code, and it was very comfortable to learn for a new person, it became popular. And personally speaking, if you ask me if I have to do something personal, I'll just quickly code it in Python, right? So that's one of the reasons why Python is popular, though almost everything can be done in almost every other language, okay? A question from Jasmine is that any book suggested for beginner learning AI? Okay. Okay, I'll have to see to it which one to pick. And you should start with this videos, the one that I'm talking about. That should be more than enough for you. Okay. And all right. All right. So I'll have to think about the book. I'll probably take a look and we'll get back to you. Come over to the discussion forum. Let me answer you there. All right. If I'm missing your questions and if your question, because question requires a lot of detailing, come over to CloudX Lab discussion forum and ask the questions there. Okay, so we have an online lab whereby lots of people do hands-on and so on, and that should help you. Okay. All right. Thank you, Gabriel. Perfect. So let's move on to the next point. Okay. Let's move on to the. So what is machine learning? Machine learning is this part that we just discussed. Okay. There are many examples of machine learning. Okay. Machine learning is basically an approach, a software approach, a change in the software approach, whereby instead of us writing the rules, let the program infer the rules by looking at the data. Spam filter is probably one of the first machine learning applications which has improved the life of hundreds of millions of people. A spam filter is a program which marks the incoming email as spam or ham. If the incoming email is not a spam, it appears in the inbox. Otherwise, it appears in the spam folder. This helps in keeping the inbox clean by avoiding unwanted emails, right? Now, even in the Google Voice, the machine learning is used to provide us with the accurate results. Google Assistant is another example. There's a pure software and machine learning is being used in it. Of course, rule-based programming is also used. The normal programming is also used. Like there will be a software, there will be a service which is listening for your for the message from here, and the service is being called, and so on and so forth. So there's the software engineering involved, the programming involved, and the one that's understanding the logic, the context, is the programmed one, is the machine learning one. Okay, like for example here. Then the recommendations. Recommendations is another example of machine learning, which doesn't seem like machine learning at all. Here, why it's called machine learning is because it's inferring the recommendations based on the historic data, based on the similarity between the people. These recommendations are provided. The people like you may also like this. Okay, now translate is using machine learning to translate text from one language to another language. Google Auto Draw is an amazing example. It has changed. Lots of games are there now on the same philosophy. It infers what are you trying to do to match your doodles with the professional drawings. All right, so that was like brief examples of machine learning. All right, now the next question that arises is that what exactly is deep learning? That was a brief introduction we took about machine learning. Now let's understand what does it mean by deep learning. Nature has inspired many inventions, like for example, the birds inspired us to fly, and the burdock plants inspired the Velcro. In the same way, deep learning takes inspiration from biological neural networks or animal brains to achieve intelligence. We will learn more about deep learning later in the course, but deep learning is a part of machine learning, or you can say the software part or the algorithm part, whereby most of these models are based on the animal brain. The animal brain. In last few years, with ongoing researches, this part of the machine learning has become tremendously useful. called deep learning because it has been able to come up with something that classic machine learning based on usual statistical analysis, machine learning based on standard techniques, were not able to solve very hard problems. But the part of the machine learning called deep learning, inspired by animal brain, has been able to do wonders, something that we never thought of. So there could be many algorithms, many design and machine learning algorithms. I'll talk about those approaches, but the deep learning approach seems to be wonderful. Like, for example, speech recognition, image recognition, natural language processing, all of them can be solved with much higher accuracy than before by the way of emulating an animal brain and feeding the data to it and then getting the results. As of now, deep learning algorithms can classify handwritten digits with more than 99.7% accuracy. It's at 99.8 now. So this is called a classic problem of recognizing handwriting. As of today, because of deep learning, this has become amazing. The accuracy is 99.8. Using the classic machine learning, the usual algorithms before the deep learning, the accuracy was close to 91%. Now this is something amazing. Okay. The question is, what is required to achieve machine learning and deep learning? What is required to achieve machine learning or deep learning? Okay. So this is another example of deep learning, where they're given a photo, we are able to recognize whether it's a cat or not a cat with approximately 80% accuracy. Given a photo, the algorithm today are able to recognize the objects of very high accuracy. All right. What is required to achieve machine learning and deep learning? Let's understand that part. The first part is that we collect data. Data can be gathered using the devices like phone or other sensors. And for gathering the data from these devices, we need connectivity. The amazing part is that this collect data part is also have become very much feasible. Today we have the phone, which has more sensors than we had imagined. And we have connectivity, which is now feasible. We have Wi-Fi, 4G, NFC, and GPS. The second part is cleaning this data. Cleaning this data to remove the errors, outliers, and noise. For example, we may have the wrong data from faulty sensors or on the robot. Or some of your customers did not specify their age during sign-up process. So we might have to clean or structure the data, and then we have to process the data. We have to process the data such that the data that we gathered or cleaned becomes consumable to our algorithms. Now, when we talk about processing data, earlier the processing was hard, but today, thanks to the parallel computing, we call it parallel computing because the things could be done in parallel. Parallel computing, one of the parallel computing examples is distributed computing, whereby you have many computers connected to the network and they're being used to achieve a single objective, say processing data. The second part is the parallel computing. The second part of the parallel computing is the GPU processing, meaning we realize that the graphics card that we used to play games with is very good with mathematical calculations. Therefore, we needed that. Therefore, that graphics card could be used for doing the machine learning calculation, because machine learning under the hood uses this matrix multiplications, using the mathematical operations in order to come up with a common model or mental model. So under the hood, it's all maths. And for that, people found that using the graphics card, the one that is used in the gaming, is very good. Okay, so while on one hand, processing data became possible using the distributed computing, meaning using many computers at the same time, thanks to the graphics card for the gaming, the processing data part became furthermore easier. Or using multi-cores, it became possible to process data using one CPU. When we say dual core, quad core, or multi-core, they all could be used. They're basically multiple processors in a computer stacked over one another. So whether using distributed computing or GPU processing or using multi-core, we are able to process data at a very large extent. Okay, I'll skip this slide because this is not really much relevant here. So GPGPU means the general purpose graphics processing unit. The GPGPU means general purpose graphics processing unit. It was designed for playing games, but soon enough people realized that it's pretty good for machine learning, and it became really, really useful to do the deep learning as well as the machine learning in general. Okay, I'm going to skip this slide now, moving ahead. So there are many use cases of deep learning in healthcare, in understanding. I'll just walk you quickly. There are many use cases of machine learning or deep learning. The first one is maybe in case of healthcare, we can find the best treatment plans according to the patient data, discover new drugs based on previous data and medical intelligence, and monitor mother and fetus health to reduce mother's worries and enable early diagnosis. Similarly, analyzing drug and medical advice effectiveness, analyze chronic disease to enable early diagnosis, and so on. In case of marketing, the machine learning could be used, or AI could be used in many ways. One is retarget customers who have already expressed interest in your product or services, then leverage natural language processing to monitor social media to understand the sentiment or real-time business decision, optimize the channel, target audience, and so on. There are lots and lots of use cases of AI in case of marketing. Then similarly, the personalized messaging based on like chatbots, and the machine vision and natural language processing are also being used in context-aware marketing. So you can use machine learning and AI to understand the user behavior on various platforms. By using the natural language processing, we can understand what they typed and so on, and we can serve the appropriate ads. Okay, let's say you are reading a particular phone model and you are shown the ad for the model on the same page. The chances of you buying the same thing is very high. All right, let's see some use cases of AI in sales. We can use it to forecast sales using historical data. We can enable predictive sales by assigning scores to lead and prioritize sales representative actions based on lead scores and contactability. Analyze the phone call data of sales representative to increase the sales effectiveness. Generate leads for your sales representatives by analyzing social networks. Track potential leads by analyzing their browsing trends and feedbacks. Use intelligent chatbots as the first point of contact with prospects. Later, high-value responsive leads will be called by live agents and therefore increasing sales effectiveness. In the fintech, there is a lots and lots of use cases detecting frauds and leveraging NLP and other techniques. So we have lots and lots of use cases in case of fintech. All right. So we can build robust credit card lending applications and anti-money laundering and reconciliation everywhere. The use of AI or machine learning is very, very common. Okay, so we can detect the frauds. We can do the financial algorithm, financial analysis, algorithm trading, or investment strategies. We can build credit lending applications. We can use AI chatbot or mobile app assistant application to monitor personal finances and gather external data such as sentiment and other marketing ones. We can also keep the regulatory, we can also cater to the compliance issues by monitoring the chat or the text. We can also do the auto trader work using the machine learning and deep learning, maybe the options or the stocks. You can maximize the profits using the algorithms. Okay, in AI and HR, there's again a lot of work, like in talent acquisition, onboarding, and improving the churn of the employees. And for common tasks, you can use the chatbots. And in the telecom companies, we can use AI for churn preventions and predicting appropriate offers for the target customers. In e-commerce industry, it's being used for cross-device personalization and many more. In manufacturing, almost this one is a very detailed one. We have done a blog on this. You should take a look at that. So creating a more efficient sales process, and there are many more applications of e-commerce in e-commerce industry. Then manufacturing companies are now using autonomous robots to automate most common jobs and functions without much human intervention. This has significantly increased the speed of production. Tesla's factory heavily uses robots for production. Okay, in sports, you can use the AI for many, many more complex decisions like, so I'm going to skip a little bit faster because I have to answer your questions. Okay. A question is neural net with NLP. Okay, please use the Q&A window. I'll take the questions in some time. All right, so we take a break after this and then we'll come back. Okay, so in sports, we can optimize the training and performance of the players, and we can also use the AI to predict the outcome of the match. In supply chain, companies are now using drone deliveries, automated vehicles, and so on. There are far more applications than you may think. In customer support, again, there are bot, virtual assistants, and there are many more. These are just very, very high-level examples. Okay. In cybersecurity, again, the AI, wherever the computing was, not sufficient. For example, detecting the attacks, uncovering the loopholes. All of that could be done using AI to a very large extent. So this was a quick summary of what we learned today. As part of this, we got to know about AI and how it's being used everywhere, the history of AI and how it came into existence, sub-objectives of AI and how AI is achieved, and what is machine learning, what is deep learning, what is required to achieve machine learning and deep learning, and use case of AI in various industries. All right. So some of the things that I have, gone past quickly because I believe that most of you will be aware about this. Okay. In case you have not gone through it, this video, the studio, there is a studio version of this studio recorded version of this presentation. You can just take a look at that one as well, because that one is free for all. The first chapter. So I'm going to take a break here, and we will start our discussion from here. Okay, we're going to start our discussion here. So we're going to After the break, we are going to start with, okay. After the break, we're going to start with Q&As, and then we will talk about machine learning process. Okay, so break for 10 minutes. Break for 10 minutes, and we'll be back by 9:50 p.m. IST. I'm in the IST zone. Please post your time in the chat. Okay, for in your time zone, I'll just all right. Oh, I don't know how to make it. All right, so we'll take a break here and we'll be back by 9:50 p.m. IST. Please post the time in your time zone. That would help everybody else. We're going to start with machine learning process afterwards. All right, so I'm back. Shall we start? All right, so before starting, do you have any questions for me? There are a couple of questions that I want to answer now. So a question from OK is that, is decrypting or encrypting one of the tools on deep learning process? Good question, good question. So maybe people are working on that part, but one of the compression tools, actually multiple compression tools, have been impacted or improved because of the deep learning algorithms. Okay. A question from Anup is, all right, so I hope that answers your question, but this is a very interesting question. I would love to research on this, that whether decrypting and encrypting is being improved by the deep learning process. There must be something. I know about compression or zooming, like image zooming, for example. Image zooming of an object has been amazingly improved with the deep learning techniques. It figures out what kind of object it is based on the understanding of objects, based on the objects it has seen. And when you stretch it, it figures out that how to stretch something without losing information or by augmenting new information. So similarly, probably encrypting and decrypting would be another research area that can be explored with deep learning. Good question. I would, if you are free, come over to the discussion forum. I would love to do a research and answer there. All right. So a question from Anup is, what is come from machine learning? Okay, machine learning, lot of examples that I just took, they have all come from machine learning. And the deep learning part, deep learning, a lot of things like, for example, character recognition, voice recognition, all of that was done by using statistical algorithms and rule-based algorithm, part of machine learning, some part rule-based algorithm, some part machine learning. But all of that has been improved further by the way of deep learning. Okay, meaning instead of using statistical or usual mathematical approaches, we use the kind of animal brain emulation in deep learning. All right, I'm going to deep dive into what it means by the neural network and so on as part of this. Okay. All right. So great, wonderful sort of set of questions. Let me just start with machine learning process. Then after 30 minutes, we will take Q&As. And because I don't have questions right now, so we will do the Q&A after 30 minutes from now. All right, so be with me. In the meantime, if you have any questions, keep asking the question and I'll take it up in 30 minutes. Do not hold on to your questions, and because you'll forget the questions. So feel free to ask questions using the Q&A window. All right? All right, so let's get started there. All right, so what we're going to talk about is the difference between machine learning and traditional approach. Understand the training and prediction phases, the various types of machine learning tasks, and understanding how to represent your data and frame the problem. Then we'll understand the training and testing phase. And then we'll understand very important concept, which is underfitting and overfitting. The amazing part of the study about machine learning is that it's actually more useful than a psychology and studying of the psychology, or you can say that it's similarly useful like psychology, because when we learn about machine learning, we learn about learning. Learning, or the way human mind works, has been mostly cryptic so far. Okay, have been mostly cryptic, and thanks to machine learning process, it is thanks to, sorry, I'm actually getting distracted. So I actually forgot to introduce myself, and I'm just realizing that part. Anyway, I'll introduce myself, don't worry, Subhendu. I'll just give me 10 minutes and I'll be able to do that. Okay. So learning machine learning helps us learn about thinking, learn about the way the mind works. And that's a very important part. Right now, when the legal definition of, let's say, learning, legal definition of bias is not the same as the mathematical definition. We talk about all the time, we talk about that person is biased, he's biased, and so on. But we really have no concrete definition of bias. Okay, so we're going to talk about these parts, and thanks to machine learning, we have a very good way of expressing it, expressing the various terms, right? So we're going to move ahead, and I'm going to go more and more detailed into it. Okay. All right. So I'm going to start with the difference between the traditional approach and the machine learning approach of solving the problems. Okay. Let's understand with a couple of examples. Let's take an example of say spam filter. Okay. We've already discussed the spam filter in the first chapter, whereby a spam filter is a program which makes the incoming email, marks the incoming email as ham as in useful one, and spam as in something that is just a spam. We don't need that. So we put it in a separate folder. So we have to come up with an automatic spam filter that takes an email and figures out whether it's a spam or not a spam. Okay, so let's take an example of this one, how the classic approach was different from machine learning. All right. Question to all of you is, how would you write a spam filter? How would you build such a spam filter? Let's take a look at the traditional approach. The traditional approach is that we study the problem, we create the rules, then we evaluate the rules, and then we launch. In case at evaluation we are happy with the results, we launch. Otherwise, we go back and analyze errors. All right. So this is the classic approach. This is how we build most of the programs. This is how we build or worked upon multiple projects. We study the problem, we create the rules, we evaluate, and if we are happy, we launch. If we are not happy with the results, we go back, study the problem again, write more rules, and then again evaluate. All right. So we may observe the subject line or the email body of the spam email generally having the words like credit card, free, or amazing, right? There could be these words like amazing, credit card, free. The moment we observe that, let's say we looked at the email by ourselves and we figured out that there's a credit, if the word is credit card in the subject line or the body, we mark it as spam. Okay. Or maybe we observe that these particular domain addresses are spam. All right. Are you able to see my presentation? No? This is my presentation. Okay, perfect. All right. All right. I'm going to pause it and resume it. Can you see it now? Some of you are not able to see the screen. All right. So I'm not that interesting to look at. Okay. In case you want to wave once, I can just turn on. Hi. So I hope you can see me. I'm Sandeep Giri, and those who are not, who have not been into my previous sessions, I'm the founder at CloudX Lab. So most of my career, I have worked on large-scale computing and the machine learning problems. And I have an experience of 16 years. I worked with Amazon. I worked with InMobi, and I worked with a company called DE Shop. And there I built mostly the large scale models on either machine learning or deep learning models. All right. I am from India, Bangalore, and we have an office in the US. So we travel to different countries whenever needed. All right. I hope that's not too disturbing to see the video. All right. So that's me, and I'll just walk you through. In case you're interested to know me. This is my LinkedIn profile. I'll just give you. Yeah, that's my LinkedIn profile. Okay. Oh, where did it go? Yeah. All right. I hope. All right. So let's. I'll turn it off in a minute because I feel that the video is quite distracting when I talk about the ideas. Okay. So I mean, it's distracting to me also. Perfect. Perfect. So when we talk about creating the rules ourselves, there are these. I'll just turn off my video because it's a little disturbing to me, and it distracts me a little bit. All right. Now I'll just focus on the ideas, and okay. So we were talking about the traditional approach. The traditional approach looks like this. So what we do is we come up with these criterias, or these rules to classify something as spam or not spam, right? If the sender's email is this, then we mark it as spam, and so on. So when an incoming email passes through this set of rules that we have written, it would be classified correctly as spam or not a spam. Now, once we've written the rules or conditions for classifying, we'll evaluate the rules on this data, and then that we have already marked as spam or ham. In case our algorithm or set of rules is giving good accuracy, we launch. In other words, it's good on the test data. We put it in production. If the accuracy is not good on the test data that we already have, we go back and study the problem and write better or more rules. So this was the classic problem. Now, what do you think are the problems with this approach? Do you think that is there a problem with this approach specifically? Yes, that's right. Continuous maintenance. Thank you, Tito. Do you see that there is problem with the traditional approach? In traditional approach, we wrote the rules, we figured out what are the rules to be written, and the system executed these rules and marked an email as spam or not spam. Do you see any other problem with the traditional approach? Yes, it can be broken. That's right. It can be broken. Yes, it can be leaked. Yes. So it can be leaked, and the spammers could actually just figure out that, okay, you have created these rules to mark something as spam, and they will work around these problems. Good. Problems with localization and translation, because you may not have worked for all the languages, and it will take a long time to actually figure out the rules in all possible languages, and therefore we want people to do a great job. Yes, that's right. Prashant, traditional approach could be bypassed by the rules. Perfect. When we create these rules manually, the rules become a long list. Long list of complex rules is what we get at the end of it. And we really don't know what all words or parameters or characteristics of the email. We basically have created this set of rules, right? Now the other part, as somebody said, that it could be leaked, and there could be, they can be cheated. Similarly, imagine that spammer figures out that you are blocking amazing, so I'll use the word fantastic, right? And now he'll have one more rule to write in order to block all the emails containing the word fantastic, right? Spammer will keep on working around our spam filter and will need to keep on writing new rules forever. And this will become like a forever going story, right? It could be like a forever cycle. And the rules keep on increasing, and will never be able to have a sustainable spam filter. Right? Now, let's take a look at the spam filter using machine learning approach. So the way machine learning approach looks like is this. We study the problem, we train machine learning algorithm using the data, we feed the data and tell the machine that, hey, this is spam, this is not spam, this is spam, this is not spam. And the algorithm comes up with the model, and we evaluate this model and see that if it's great, we launch it. Otherwise, we go back to analyzing the errors. And therefore, here, the algorithm is figuring out the mental model, the way me and you infer that what is spam, what is not a spam. Similarly, the algorithm is figuring out whether an email is a spam or not spam. It's not only based on a keyword or an IP address or only the domain address. It could be a combination of all of these. And these rules are automatically inferred from the data. Therefore, in case we realized that we have a continuous data being reported by people, people are reporting that this is spam, this is not spam, we can utilize that in order to make it a full cycle, right? So this cycle can be automated. This cycle could be automated. We got more data, we train a machine learning algorithm. If it's giving good solution, we launch it. And we get more data, and this cycle could continue. This way, we will have amazing spam filter. This is something we don't have to keep on writing the rules. Instead, the algorithm is figuring out by itself. It's going through all the emails, understanding what it means. And this is possible only if we have this data which has already marked emails like this is a spam, this is not a spam. So our machine learning model learns from this data and comes up with a mental model, and we evaluate that mental model here. Okay, I'll talk about what does it mean by model very soon. So the other example I want to take is speech recognition. Speech recognition involves inferring what is being spoken. Basically, it is the conversion of sound into text, right? So on one end, somebody speaks something, it is like a signal, as in the strength of audio. And based on this wave, we want to figure out whether it's 1 or 2 or 3 or 4. Just I'm taking a very rudimentary example. So given the speech recognition, we want to figure out what they just said, right? So we could come up with a manual model. Okay, we could use a traditional approach whereby if it's a high pitch, it's 2. If it's not high pitch, it's 1. Okay. Now, this traditional approach has certain problems. What do you see as the problem in this traditional approach? Yes, anybody? This is a traditional approach whereby we are seeing a graph or a wave of the wave, and then coming up with wave matching kind of model manually, and matching whether this wave is same as this wave and marking it as 1 or 2. So what problem do you see in this approach? The high and the low pitch is relative to the speaker. That's a good point. Thank you. It could be different for different people, right? Okay, so yes, we could right? Problems with traditional approach is that it will not work for words spoken by millions of different people. Or there could be noisy environments. So rule-based system doesn't work so well because rules are hard to design. So in such case, a deep learning or machine learning approach is far better. Similarly, the rule-based approach will not work with the voices of people in different accents. Somebody has said localization translation in previous, I think Erika has said, and yes, that's true in this case also, that if there are accents, there are different kind of languages, in different countries and so on. So the classic approach of writing rules will become really lengthy and very hard to diagnose and hard to maintain and so on. Okay. Therefore, this approach did not work. Earlier in the companies, there used to be separate team. This is audio analysis team, this is video analysis team, and this is the image analysis team, and so on and so forth. Today, almost all of these teams have merged into machine learning team. Why? Because the classic approach did not work so well. Therefore, in Google's or Amazon's, these teams who used to be very isolated, they were not too overlapping with each other. Today, they have much more overlap because most of the work is being done using deep learning. The speech recognition using ML, machine learning approach, is we have data recordings of each word by millions of people. And then program basically learns by itself what does it mean. So we have labeled recordings of people, somebody saying 1, 2, 3, and so on. We feed this data to program and say that, hey, this means 1, this means 2, this means 3, this means 4, and so on and so forth. And this way, the program, when it listens to millions of samples, it figures out what it means by 1, what it means by not 1 but 2, what it means by not 1 and 2, and so on. So this is something which is basically this is the approach that we follow when we talk about machine learning projects. How can machine learning approach improve our understanding of subject? This is a very important part, the very important part. the way we figured out that there is a bug in Mario game, right? When we saw the Mario example, we figured out that a machine figured out that there's a bug in the game and it's exploiting it. So it gave us more ideas. It gave us that this can be done. Similarly, in many more problems, we get more clarity on the problems by using machine learning. The machine learning approach can help us understanding the subject better. For example, in case of spam filter, our algorithm can reveal the list or the combination of words, can reveal the list and the combination of the words that it believes are the best predictors of the spam. Sometimes this will reveal unsuspected correlation or the new trends, and thereby it leads to a better understanding of the problem. So it could give us these ideas that, hey, these are the keywords, not the ones that you were thinking. These are the keywords which have which are more common to the spam, or combination of these, or combination of this along with the IP address, and so on. In some cases, there are many more things that I'll talk about. In some cases, it will figure out that it's about spelling mistakes that's causing it. All right. So let me talk about machine learning process. So we talked about how the traditional happens, how the traditional process is there, how it's a new way of doing it is different from the traditional one. In the traditional one, we sat down at the problem, looked at all the rules, figured out that these are the rules that we should write, and then coded those, right? In the new world, in the machine learning world, what we do is we feed the data to the model. We do the training first. By the way of training, we get the model, and then from the model, we get the predictions. Training is the phase whereby we generate the model, just like in humans. Kid plays, kid goes to school, the training is going on, and mental model is being built. And then that using that mental model, when the kid becomes elder, he can perform bigger tasks. He can play football and so on and so forth, right? So similar to the humans, is the case with the machines. We train, and the mental model builds up, and then we use that model to do the prediction. Okay. Let's look at the training phase. What happens in the training phase? The training phase looks like this. We have collect the data, clean the data, process the data. So what we do is we take the data containing historical emails, and then we have this algorithm which will basically learn from data automatically. We have data containing historical emails, as well as there's a label associated. We have the label marking that which email here is spam and which one is not a spam. And we have the algorithm which learns from this data automatically. And what we get is the trained model, which is used for prediction. Now, that was the learning phase. The outcome of learning phase is the model. Now, this model is not like full data set. This model is a tiny information. And this model can be used at a really fast pace in the production environment. During the time of prediction, we also call it inference. Okay, so when you get the new incoming emails, we feed that to the model. It tells us whether it's a spam or not a spam. This phase is called prediction phase. So in other words, we have data. So this is a training phase whereby we got the data. We feed that to algorithm. It gives us the model. Algorithm is a program, is a software, is basically the rule that we wrote. Okay, there's a code, there's an algorithm. Okay, and this algorithm generates the mental model. Right? So we got the data, we feed it to the algorithm generates the model, and using this model, we can feed the live data and it can do the prediction. Now, let me take this part further. What we do is, the most important part is that whatever data we have, we need to convert it into features, labels, and instances. Okay. All right. So imagine that we have the emails of people, right? Emails, let's say it is this format. So the first thing that we generally do is convert our data into a tabular form. Whereby each row contains an observation or a reading. Here we are saying that this is our first email. It has this subject line, and this is the sender, and it's a spam. So this is called the label. Okay, so this is called the label. These are instances or readings, or you can say observations. All right, and these are features. The characteristics of these, of each of the instance, are called features, attributes, or characteristics. All right. So we convert our data into this form. So you can think of features as attributes of an object. For example, color, size, taste are the attributes of the apple. Right? For example, color, size, taste are the attributes of an apple. And this is called the label. Label is somebody has marked it manually that this was actually a spam and this is not a spam, and so on. These are called instances. We have 3 instances having 2 features. One is subject and sender, and one label saying spam or not a spam. Okay? So each row in the input data is called instance, reading, or observation. We will further again learn about what is feature, instances, and the labels in more details. Okay? Right now I wanted to keep it more detailed. I did not want to keep it more detailed. Let's just move to the next chapter, and then I think then we'll take up the, yeah, this is the one. Okay, so let's okay, so that was our quick example of okay, let me just exit from here. Okay, so here we go. Perfect. Now, do you have any questions for me at this point of time? Okay, so these are called instances, it's a label, and these are features. All right. So do you have any questions? Let me answer your questions now. Okay, so let me just take this, put all these things together so that this makes sense to you. Okay, and these are called features. Perfect. All right, so let me answer your question. A question is, what is the difference between ML and AI while using for the project of AI and ML? Okay, so, all right. The AI is an objective saying that something which is intelligent, which has sub-objectives, which has any of the sub-objectives at least, and that's AI, and ML is the approach. ML is machine learning is the approach. But the unfortunate part is that AI and ML is being used interchangeably. AI is also used as a substitute for ML. So I think that would give you more clarity about the idea. So let's just focus on this approach that I'm talking about, okay? Whereby we should understand the difference in classic and now, okay? I can actually give you all possible definitions of the word, but it may not help you in any way. Therefore, I moved on to further about the observation, feature, and label, because this is very useful when we are working on a project. It's basically the difference between the classic project and now is the approach underlying. Okay, the problems are same, problems are not different. It is the approach that has changed, and because of the change in the approach, what has happened is the accuracy, the performance has improved dramatically, and that has also given us courage to solve the hard problems that we thought were impossible earlier. A question is how to introduce or initiate ML DL project in a company. The classic way is observe what is not being done what is not being done by computer. So I was talking to one of my friends, and he is in a fintech company. So I was observing that, I was asking, like, what are the things, when I asked him that, hey, are you guys doing some ML AI project? They said, no, we are still the classic company, we're not doing much of ML AI. Now that's a very interesting part. So the way I changed my question was, instead of asking that, hey, do you have any AI and machine learning project? Instead, I asked, like, where are you stuck? What is your pain point? Where are you? What do you do in general? And then I observed that which are the parts that are manual, which are the parts that are less efficient, which are the parts that can be replaced with a faster algorithm. So that's a very important part. And for that to figure out, you must know the limitations and the capabilities of the current algorithms. All right, that we will discuss in more details as we go ahead. Great question. So a question is, image processing is an application of deep learning. Image processing can be done using standard algorithm. Even zooming an image is an example of image processing, or applying a filter on an image can be an example of classic application and machine learning. But the important part is this. It is, what exactly are you trying to achieve? Can it be done better with deep learning as compared to the rule-based approach? That is more important. So image processing has many more new algorithms, like face recognition, for example, object detection, for example, detecting in this photo, where are the people? So if you take a look at my blog, I just posted how to build a camera which detects people and rotates. Okay, so image processing is definitely one of the areas where a lot of work has gone in, not only using deep learning or machine learning, but also using classical programming approach. R language is for machine learning. It doesn't matter. You can use any programming language. All right, moving ahead. So in the example of email, where the email subject changes from great offer to amazing offer, how does the algorithm learn? Or in any case, where the data changes drastically, how does the algorithm be able to predict? Good question. So maybe the algorithm will come up with these patterns by itself, looking at the historical data and seeing that some of the spam actually has amazing, and some of the spam has great offer, but it's some other characteristic of the email. If, let's say, amazing word is being repeated 15 times, so it'll come up with that. A question from Vijay is, I assume that once we train the algorithm, we are not going to train it again. We are going to train it, retrain it when we receive more labeled data. We will train it again. We will train it again so that it can do better predictions. And because this mental model will get stale. Like in case of us, humans, when we learn about something and the technology changes, we have to retrain ourselves. Similarly, the case with the algorithm. Soon enough, new data will come in, more people will mark spam and not spam, and the algorithm will update the model. A question from Inderpreet is that how to decide which activities be led to hook up or to be made rule-based. Good question. So general thumb rule is if you have some amount of information or data, or if you have something called pre-trained model, I'll talk about pre-trained model whereby somebody else has done a similar training. You can just borrow that model, like for example, face recognition. If you have pre-trained model for the problem that you're looking for, then you don't need to you don't need to write everything from scratch. Like for example, one of the projects that I was working on, whereby we were looking at the photo and we were measuring the sizes of a person, like the size of the waist, size of we were taking the measurement of the clothes just by looking at the photo and knowing the height of the person. So based on that, we were figuring out the various dimensions. Now, we don't have enough data to come up with, train a machine to figure this out. But what we realized was that somebody else has done on a similar work. We borrowed that model, that mental model of the algorithm is available to everyone. So we use that model, we call that pre-trained model. So you can, to decide what can be done rule-based and what can be done machine learning is number one, is there a pre-trained model available? Do we have data? If not, we might have to do rule-based. Okay. Initially, what we'll do is we'll do it rule-based, and then gather the data, and then we improve the process. Wonderful set of questions. How to know the features of a data set for training the model? Good question. So how to know the features of data set? So first of all, you'll have to take a look at the problem. Take a look at the problem, that what is it that we are trying to identify? What is it that we're trying to predict, right? That becomes the label. And on what criteria are we trying to predict something? Those becomes the feature. And what is it? The whole thing. That's called the instance or observation. Okay, so you will know once you have the picture of this one in your mind. When you have picture of the email example, you will be able to figure out what are the instances and what are the features. Okay, again, coming up with the features is a hard problem. Coming up with the features is a hard problem. So say, for example, I was trying to predict the suicide rates based on certain parameters. And then I soon realized that the countries with highest population are having the highest suicide rates. So it's not the suicide rates in general, suicide numbers in general I need to calculate. Instead, I have to come up with the rate of suicides per population of that country. So that was more useful. So we have to be careful about features. Again, there is no right or wrong about the features. So the way we do is we observe, we understand the problem, and then we convert that problem into instances and features. There could be hundreds of features, right? They could be like, we could convert the body of the text as something, as a certain other features. We could also bring in the domain name. We could also bring in the IP address and the country and so on into this email, and they all become features. So feature set identification or feature engineering is a hard problem. If you are from the same domain, if you understand the problem, the chances are you'll be able to come up with better features. All right, let me answer some more questions. These are wonderful questions. So, all right. So it seems that the efficiency of an ML system could depend on the set of data that the system used. All right, so this is a hard question. Question is, it looks like the ML model's efficiency depends on the data set. What data are we using? How would we know that is it the algorithm or the data that's at the fault? Is that your question? So how would we ensure that it is the system and the model is correct in this case? How would we know that is it the data wrong, or is it is it something to do with our algorithm? So yes, that's where the understanding of the machine learning comes into play. So you try not only one algorithm, you try multiple algorithms, right? And then observe, are all of these models giving bad performance than a random toss? If they are just like really bad in accuracy, all of the models, the chances is that your data is garbage. Or you need to look at your data and understand the features and instances again. Wonderful question. Question is, what is unstructured data and what is structured data? Come over tomorrow morning. I have a session at 7 a.m. on Spark. I would love to take you into the details of structured data and unstructured data. All right. So come over to the CloudX tab. We have there in the notifications, you'll see in the events. We have all the upcoming events there. Tomorrow morning, we have a free session on Spark. So come over. I would love to describe in more details. All right. A question is, I'm working on the data set, but I'm getting the error in coding, although my concept related to training is clear. But by using GitHub code, the error is not resolved. All right. All right. I would suggest that come over. I would suggest that this is if it is related to the coding problem, probably leave it on our discussion forum. I would love to answer the question. Okay. Probably then I'll have to take a look at your code. All right, and come over. We have tomorrow a big data session on Spark. I'd love to answer your question there. Wonderful questions. So I'm sure that for many it's too late, or for many it's too early. Okay, now let's move ahead. And the other part that I want to discuss is the types of machine learning. This was the basic understanding of the two different approaches. And though it might look very technical, but trust me, if you are going to manage a machine learning project, you need to be aware of the terminology, the process, and the understanding about these concepts. Okay. A question tomorrow morning we have in same meet. If you are coming from Meetup, I'll just give you the link in case you're interested. All right. So let me take a look at here. Notifications, this one. Okay. So in case you are interested in the big data, tomorrow morning I have a session. So come over. I would love to explain to you what it means by data. All right. Wonderful. Great. So let's get started with a very interesting topic. I'll just take 10 minutes and then we'll take the questions in more details. Perfect. So great set of questions. Wonderful. I'm really happy that we have a really great audience. Now, moving ahead. So that was a brief introduction of what is features, instances, and label. I hope everybody's okay so far. Yes? Yes, Rico, you have a question. You have raised a hand. Please type yes in the chat box in case you are okay so far. Shall we move ahead? Okay, so looks like only 4 people are awake. All right. Okay, please type yes in the chat if you are listening. Not in the Q&A, the chat. Perfect. Perfect. Looks like quite a few people are listening, and I haven't put everyone on the chat, everyone to sleep. All right, so let's get started with another topic called machine learning types. This is a very important aspect of machine learning. Okay. Okay. So I'm going to start with this photo. How many of you know this photo? So on this side, yeah, on this side we have Ex Machina, and on the right hand side we have I think it's called Machina, not Machina, and on the right hand side is a robot by Boston Dynamics. So in simple words, this is where we want to reach. This is the fantasy, while this is the reality, and the way is by the way of data. By the way of data. So all right. So machine learning can be classified. Give me a moment. I'll basically. Okay. Let me make it full screen, and now perfect. All right, so there are so many different types of machine learning systems that it is useful to classify them in broad category, whether or not they are trained, whether first one is whether or not they're trained with human supervision. Okay. Second one is learned incrementally or not. That's another criteria to classify. The third one is how well they generalize. Now, something that is based on human supervision, the machine problems can be divided into 4 major categories: supervised, unsupervised, semi-supervised, and reinforcement learning. Now, the first thing I want to discuss is what does it mean by supervised machine learning? Okay. In supervised machine learning, the training data you feed to the algorithm includes the desired solution. Okay. So the span filter that we talked about was actually supervised machine learning because it has the desired solutions called labels. We tend to predict the values of classes based on the given data set. Say we want to predict the value of a house in the US from the given data on the houses. So we'll have the information about the house, and then we will have the label. Right? So on one hand, we will have the fruits. On the other hand, let's say we have the data in which we have the photos of the fruits, and they are well labeled. These are called supervised machine learning. Supervised machine learning because we have the training data available to us. So this is called supervised machine learning. In supervised machine learning, we again have two kinds of things. One is called classification, other is called regression. When we want to classify something into a bucket, like for example, we have objects and we want to classify them into aeroplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. So let's say we want to predict the label. That's called the classification. Spam filter is a classification, right? Classification supervised machine learning, right? Similarly, given the image of handwritten character, what is the number written there? 0, 1, or 2, or up to 9. We have to predict one of the labels. So this is again a classification problem because we have 10 labels and we have to classify given image into that label. It's a supervised machine learning problem because we have training data available to us. We have training data available to us saying that this drawing is 1, this drawing is of 3, this drawing is of 10, this drawing is of 9, this drawing is of 8. This problem is known as MNIST, modified measurements and something. Okay, I'll talk about that one later. So this problem of handwriting recognition is a well-known problem, and it was done for a long back. The second supervised machine learning is regression. Regression is, let's say you want to predict the price of a car. We've given the historic data of the cars having various features, also called predictors, such as mileage, mileage, age, brand, etc. So we are given the features of various cars along with their price, historic data. And we have to predict that given the characteristics of a new car or an unseen car, we have to predict the price of that car. That's basically the regression problem. Or in simple words, let's say given the years, how old is the kid? We want to predict the height or the weight. And we have the historic data about the kids and historic data on weights and heights of the kids. And we want to predict that on this age, what is the height or what will be the height or the weight, right? So this way they can utilize the machine learning to predict this, and such problems are known as regression problem. Okay, these are regression supervised machine learning. This is regression supervised machine learning. Now, another question comes in that what is unsupervised machine learning and is it any useful? So unsupervised machine learning, one such case is called clustering kind of problems. So clustering problems is we don't have labels, we don't have any, we have training data, but we don't have labels marking that this group is called A, this group is called B. We don't have that labels. Instead, we are given that here are the users, classify them into, say, 5 groups, okay? And we have to just analyze this data and come up with, say, 2 groups, 3 groups, or 5 groups. So imagine that we have a blog which has many users. Say we want to form the groups of users such that similar users are in the same group. The similarity could be based on how many posts they have read, their city, their topics of interest, etc. We don't have a label or the value to predict. Instead, we group the users together. Such a group could be useful in identifying the outliers and also in the understanding of user behavior. We don't have predefined set of rules. At no point we tell the algorithm which group a visitor belongs to. Instead, we let the group formation happen automatically. Such tasks are termed as unsupervised machine learning tasks. We might come up with really good insights, say 20% of the people are sci-fi lovers, 40% are comic lovers, and so on. Similarly, the other kind of clustering is called hierarchical. Hierarchical. Now, what does it mean by hierarchical clustering? This is something what Charles Darwin did, given the characteristics of all the species of the world, come up with a hierarchy, come up with a tree, come up with a correlation that there is a tree, right? So that's what is known as hierarchical clustering, and it's an unsupervised machine learning problem. We don't have label marking that chimpanzee or human belongs to the same label. We don't have historic data saying chimpanzee and human are supposed to be the same bucket. It is based on the characteristics of the species. Okay, as a result, what Charles Darwin did after a lot of research, today, if we feed the same data to our algorithm, it'll be able to come up with that correlation what Charles Darwin did. All right. This is known as, this is an unsupervised machine learning problem because we don't have labels. And third way of categorizing machine learning problems is okay, I'll just move ahead. So this is another example of unsupervised learning called anomaly detection. Say, for example, we want to predict that this particular credit card transaction is unusual and maybe a fraud. Okay, that's supervised and unsupervised, and semi-supervised is somewhere between unsupervised and supervised. Okay, semi-supervised is we have some part, small labels, but not all the labels, so we infer some relationship and so on. So somewhere between supervised and unsupervised is semi-supervised. Third one is the reinforcement. What we did with Mario was an example of reinforcement learning. We have the environment where our agent plays around and it knows that what is wrong, it gets the reward or punishments, and based on that, it comes up with the policy. So that's called reinforcement learning. Reinforcement learning has many examples: playing games, creating a robot, and many more, right? The other way to classify machine learning problems is whether they can learn incrementally or not. If the algorithm or the program or the machine learning problem that we are trying to solve, does it require that our program keep on learning continuously? As in, when new data is coming, it's learning from that. That's called online learning if it's learning continuously. Otherwise, it's called batch. Okay. So in the batch learning, the learning is slow, in the sense that we gather the data, run the algorithm, it looks at the entire data set again, and comes up with the model. That's batch learning. And when it can learn incrementally, as in when new data set is coming in, we call it the online learning. All right, I'm moving ahead from it. Next is, I think this diagram is more important. So as in when new data is coming on the fly, we are learning and moving ahead. Okay, I'm just moving ahead. There's not much required. Okay. All right. Now the last one is an important part. I want to just take 1 minute to describe this part. So the third category of the problem, third categorization, is based on how well they generalize. How well they generalize. One is called instance-based and other is called model-based. Okay? The most trivial way is by learning by heart, meaning memorizing things, right? So let's say this is the data, and given the position, so this is, let's say, one feature, this is another feature. So here, imagine that this is one instance. So for this feature, this value, we have square. We categorize it as a square. For this again is square, while this one is a triangle. Now, given the position of a new point, we have to predict whether it's a square or a triangle, right? So one common way that we do is that, okay, we memorize everything in the history. When we see a new instance, we compare it with the neighborhood, who it is more close to. And we see that, okay, it's more close to the triangles, so let's call it a triangle. because it's more close to the triangles. This is called the instance-based learning. Given a new instance, we basically compare it with the history, like the way most of us actually do, that when we look at somebody, when we look at somebody, we say that, oh, this guy looks like those guys, and therefore his behavior is going to be like that, right? So that's basically instance-based learning. We have memorized the history. We haven't come up with a mental model, okay? So if we memorize everything and we do the matching, that, okay, he is very similar to him, and maybe his behavior is going to be like that, right? His appearances are like that, so maybe his behavior is also going to be like that. So that's kind of instance-based learning. We've memorized everything, and then we are comparing. That's called instance-based learning. While the model-based learning is that we figured out what is that line, what is that model. We figured out that there is kind of a curve that separates the triangles and the squares. And when the new instance comes, instead of telling that, hey, this is more closer to the squares, it tells that it's a triangle based on this model. It has figured out that there is a relationship, there is a model. This is the line that we call it a model. This line is called the model. And based on this line, is telling that, hey, this is not really square. It's actually a triangle because it comes towards this side of the line, right? This is called the model-based learning. All right. If you have questions, I would love to answer those questions right now. Looks like you don't have questions, or I have put you to sleep. Okay, so that's about the machine learning types. The next thing that I'm going to discuss in the next session is the next thing we're going to discuss is how to represent data, and then we will understand what does it mean by underfitting and overfitting. Okay, but I would like to actually take you through the underfitting and overfitting, and right, there's something that is very, very needed. Okay, yes, I'll explain to you the reinforcement learning, don't worry. All right, perfect. So I'll explain to you. Okay, a question from Rico is, can you show us how formulas for anomaly detection? I need for my journal. Sure, sure. Could you come over either of the email or the forum? I would love to give you in the details. Maybe I'm not able to give you right now, but I can give you more details. Okay, because this is something that I would like to give you in more details. Perfect. All right. So a very common thing that we want to understand and we should understand about machine learning. I'll just finish this part and then I'll take your questions. Great. All right. Perfect. I'll just give me 2 minutes and then, yeah. So this is something I want to explain in 2 minutes. That is something going to be really useful to all of you. Okay. My email address is reachus@CloudXLab. Perfect. All right. So very common thing that we need to know about our algorithms is that how well they're learning. Now, it might seem like a simple problem that, hey, if something is learning, that means learning, right? But how do we define learning? And that's where the idea of underfitting and overfitting comes into play. Okay. So though it's a mathematical term, but I'm going to take a very simple example. Imagine right, just give me 2 more minutes and I'll be able to explain this. So give me 2 more extra minutes. I feel that this is very important and we all should learn this. Okay. So I want to help everyone understand what is underfitting and overfitting, and then I'll take a question. So it's very important concept as part of the machine learning, and something that is very useful in our normal life as well. Imagine that there are 2 kids who prepared for a maths examination. First kid, let's say Tom, he learned only the additions, not the multiplications. He skipped subtraction, multiplication, and division. He only learned additions, but he can do additions really well. Now, there is another kid whose name is Mary. She has really good, amazing memory and studious. So what she has done is she has memorized all the problems from the maths textbook. So she memorized all the problems, whether it's subtraction, division, multiplication, and so on. So she memorized all the problems. Now, in the exam, Tom will be able to solve questions related to only additions and will fail in the questions related to subtraction, division, and multiplication. So, and Mary will be able to answer any question you ask from textbook, but she will not be able to answer the questions which she has not memorized, that was not there in the textbook. So here, both Tom and Mary will not be able to perform well in the exam. Maybe Mary is able to solve, say, 25% of the problems because they appeared as is from textbook, while she will not be able to solve other problems which she has not seen before. While in case of Tom, Tom can solve all the problems related to additions really well, whether seen or not seen, but not able to solve the other problems. So both Tom and Mary will not be able to perform well in the exam. In case there is an exam in which all the questions came from additions, then Tom will be able to do good. If all the questions came as is from the textbook, then Mary will be able to perform well. But in reality, both will fail. We call Tom, who learned only the additions, we call such algorithms which only learned some part, not everything, some part. We call them underfitting. On the other hand, the algorithms that memorize entire training set, we call them overfitting. So we got underfitting and overfitting. All right. So we'll take more examples in the next session. I hope this is clear to you. All right. Let me answer your questions now. A question is, there is no training set in supervised learning, in unsupervised. No, there is training set, just that the label is not there. We have, let's say, we're giving a bunch of emails and said that, can you figure out the grouping in these emails? Okay, so we come up with a characteristic similarity criteria between the emails and we group them. That's unsupervised learning. Okay, but we don't, like spam filtering, we have a label saying this email is a spam. Okay, that's supervised learning. Spam filter is a supervised learning. While if we're giving the email and said, hey, these are the bunch of emails from historical data, can you just break them into 5 categories on some criteria? So that's unsupervised learning. A question from HP is that, explain reinforcement learning. Reinforcement learning is the example that we talked about in Mario, where there is an agent who is exploring the world, gathering the data and learning from the data and continuously getting rewards and punishments. And that's how it's learning continuously. That's reinforcement learning. All right, so that's pretty much for today. We are going to go more detail in the next session. Those who have not enrolled for the course, they can enroll from the website. This course is a deep dive into machine learning and AI for everyone, even if you have no background in computing, if you have no background in machine learning, okay? No background in coding or maths, okay? So come over, join the course. I would love to answer your questions, and I'll try my best to help you understand the hardest concept of machine learning without getting into code, okay? Again, the way I'm trying to balance this course is, or we balance this course is between the underfitting and overfitting. We're not making you memorize all the ideas so that you can't predict. At the same time, we don't want to leave you at this point, just basics of it, just learn one concept. We want to go in more details as we go ahead. This course is actually very deep dive and unique in its own way. You will learn the hardest concepts in more humane way. A question from SP is how to solve the problem of overfitting. Good question. So in very short, we use something called regularization techniques. And there are many regularization techniques, meaning forcing the kid not to memorize, instead come up with a model, okay? A question from Rico is can you explain how to know model we are using underfitting or overfitting? Just like, good question, good question. So I'm going to go more details. For now, let me just give you a quick answer. We just ask if let's say a model is performing bad on the on unseen data, but if the model is performing great on seen data, that means the model is overfitting. All right. In case model is overfitting, we have to force it not to memorize. In case model is underfitting, we have to make the model a little more complex so that it can learn better. All right. So this course doesn't end here. This is just first free session for all. From next session, which is going to be on next Saturday, you can enroll for the course, and we'll go into more detail about the AI and machine learning. All right, so come over to CloudX Lab and take a look at the course. And if you have any questions, just feel free to reach out to us reach us at CloudX Lab at any point of time. If you have any technical questions and you want to go more detail about a particular kind of problem, come over to the discussion forum. All right. All right. So thank you, everyone. I'm really happy that 50 people, at least 50 people, stayed till the 3-hour session. I'm really, really happy to have wonderful audience. I look forward to see you all next Saturday. Till then, have a great day. All right, have a great week ahead. I look forward to see you next week. This course is going to be extremely deep dive without the coding and maths. Okay. And so thank you, everyone. I look forward to see you next week at the same time. Bye-bye. Have a good day. I hope that today's session was useful for you. In case you are just exploring this area, I'm sure that you will have learned at least something today. All right, great. Have a good day and bye-bye. Thank you, everyone. Have a great week ahead. Bye-bye.